Are you starting to create a design system library from scratch for your company? Or do you want to know more about design tokens, Storybook, or shared component libraries? I'm Costa Alexoglou, Senior Software Engineer at Neo4j, and I will give you the tools you need to create flexible, enterprise-grade design systems that your coworkers will love. But why exactly are more and more companies creating their own design systems? First of all, it increases developers' productivity. Developers will stop trying to replicate work that other teams have already done in their own code base but was never shared. Also, it creates consistency, and this is something enterprises or even smaller companies really care about as soon as they start having more than one user-facing application. And the last reason is that building velocity is increased. With a design system in place, developers know where to find branding assets and can grab components off the shelf and start building. This eventually leads to developers spending more time solving hard engineering problems and less time styling things. In this course, we will learn how to create a yarn monorepo, how to create design tokens with style dictionary, create a component library from scratch with React, create a Tailwind CSS preset, test for accessibility issues with Axe, conduct visual testing with Chromatic, and the last chapter will focus on how to publish our design system with change sets and GitHub Actions. The only thing you need to know before this course is basic knowledge of JavaScript, CSS, and a hands-on experience with any UI framework like React, which is the framework that we will use for the component library. That's a wrap, and let's get started building our own design system.
If you want to keep learning about how to build real-world apps with the latest technologies and other career-related topics, then start right now by subscribing to our channel and liking this video.
Probably you've chosen this course because you already noticed that design systems are exploding. But why is that? First of all, they create visual consistency, and our company probably doesn't want to end up a meme on Twitter, like Steam, for example, where they have thousands of buttons, thousands of drop-downs, thousands of search boxes. A second important reason is that the developers' productivity is actually increased, and two examples: the devs can find components ready to use instead of building them from scratch, and they can reduce time finding branding assets, for example, logos, colors, and more stuff that are really hard to reach if we don't have a centralized place to look for them. Some other reasons: we have a single source of truth. We have Figma and Storybook in our case. We have better brand memorability, which brands really care about. We have also functional consistency, and we can check the example of the two buttons that you have a different speed in the loading spinner. And this is just for a button. We can have different animations in drop-downs, in sidebars, and this can deviate really much in different user-facing products of our company. And the last reason is that we can focus on solving hard engineering problems rather than styling components. Also, below in the description of the course, I have attached some examples of some really good design systems that I admire. For example, Evergreen from Segment, Garden from Zendesk, Paste from Twilio, and Adele, which is a design system repository, so you can find some inspiration and look at best practices. So now let's lay down the fundamental concepts of a design system. The four fundamentals concepts we need to know before we move forward include: what are design tokens, what is our source of truth, and two meta models I really like working with: the pace, layering, and atomic design. So let's start with design tokens. You may have heard about design tokens from here and there, but what is a design token? A design token basically is a tiny piece of information, a raw value, that will be used across several of our digital products. A design token can be a color value as a hex string, or an RGB, or an HSL value, a spacing value in pixels, an animation or a shadow, and many more values that can be represented by a single value. Moving to the ground truth, how do we actually have a ground truth in our design system? We usually use a design tool like Sketch, Figma, or Adobe XD, but this can be actually anything, like a Google Sheet if we want to be old school. In this course, we will work on a single Figma file containing all the important information we need. And the elements we need to start building the design system will include branding colors, typography, borders, shadows, spacing, and some common components like a button component, for example. Now, the first of my two favorite mental models when I think about design systems is the pace layering thinking. And this concept encapsulates the idea that slow-moving things in the heart of our design system will bring the biggest changes on the outer layers when they will change. In our case, in the heart of the design system, we will have the design tokens, and we expect that when we change a design token, all those changes will propagate to the symbol and to the more complex components. And the second mental model is called atomic design, and many components libraries are actually using this. This model was first introduced by Brad Frost and described how atomic components can evolve to more complex organisms. Later on, a new phase was added called ions, which is basically the face of a unit of information, in our case, a design token. And now that we are familiar with some key concepts, let's move to the Figma file and start translating our design to engineering specs. So, our design system's source of truth is in a Figma design. So let's examine what we have and how we can define our requirements. We start with this Figma file, and on the left we can see all the pages. Now we are on the cover page, and let's move forward to the spacing page. So with the spacings, we can see that we have multiple spacings defined, and all are multiples of 4 and 8. So we can see here we have 4, 8, 16, 24, 32, and 40, and it goes on and on. So the first question we ask ourselves is, can we model the spacings into a design token? And the answer here is yes, as they can be represented by a simple key value pair. So in our case, let's open Sublime. And in our case, the value would be something like spacing, then 4, and it would be 4 pixels. And that would represent a design token value. So moving forward, we can see the colors. Again, this is the whole color palette, and we can see quickly that the values can be represented by a single key pair value. And look something like, let's open again the Sublime, and the color could look like something colors. See here, colors, then primary. So we choose our primary color, and then the 500 shade, and this would be, we would extract the value 556, or let's see this value here, which is this one. So this is our color token. Next, we have some effects. Again, we have the shadow effect, two shadows, level 1, level 2, and the rounded corners. So a small rounded corner and a large rounded corner. And this is again the same principle. We can use design tokens for those two effects, the shadows and the rounded corners. For the typography, things start to get a little tricky. But why is that? Let's examine, for example, the heading 1. We can select heading 1 and check here the styles. So if we see the properties, we can quickly see that we have multiple values for a single text style. Those properties and values are font family, font weight, line height, and letter spacing. So this is not an ideal case for a design token format. Usually, this is tackled with a platform-specific solution. And in our case, as we will focus on web-based components, we will publish our design system with a typography.css file that will include all of our typography stylings. And we have a demo here of what it would look like. And again, you can find this link in the text of this specific lesson. Going back to our Figma, and let's get to the components and the button component. Now we can briefly see the component, and especially the button component. As we can imagine, a button cannot be a design token per se, but what about a really small detail that we notice about the animation? Here we see that transition between states is 400 milliseconds is in and out. This could be easily added as an animation token, so all of our components will use in a format like animation and the default animation if we have only one animation, and then paste this value, which is 400 milliseconds, and the is in, is out effect. So that was all, and we will move to the next module where we will start our Monorepo and get some hands-on coding. And in module 2, we will see how we can actually create the design tokens and make them consumable with Style Dictionary. So let's see now how we can architecture our Monorepo so that it will be easy to work with and maintain. Here is an example FigJam of how our Monorepo will look like. In the bottom, we can see that we have Figma as our design truth. And then we have 3 packages contained in our Monorepo. The first package is the foundation package. And if you remember from paste layering, this is the kernel of our design system that will host all of our design tokens. Then we have the component library, which will of course host our React components, and it will depend on the foundation package to consume the design tokens. And the last package that will help us develop and document our design system, it is the Storybook package. And to see how it will look like, this is the Storybook. Here we have a simple button component. This is a simple React button component that consumes our design tokens. Here we have different colors, and this is our typography. So let's move forward to start actually building our Monorepo. So it's time to get hands-on and start building our Monorepo. To build our Monorepo, we will work with Yarn workspaces. And this is a really convenient feature of Yarn to work with node-based monorepos because it has some advantages like delegating and duplicating dependencies, running package scripts directly from the repository root, and it also handles symbolic package dependencies, which in our case is extremely useful because, for example, we will have React package depending on Foundation and Storybook depending to React and Foundation at the same time. Before jumping to the terminal, we need only 2 dependencies, Node and Yarn installed on your local machine. If you have those installed, let's jump to the terminal. We have an empty Git project, and the only dependencies we need is Node and Yarn. So we can check which Node version we are using, so the version 16, and which Yarn version, the 1.22. So in this course, we will use the Yarn version 3, and to work with Yarn version 3, it's really easy. We just run yarn set version and bury. Bury is basically the version 3 of Yarn, and everything will be done. So if we go to our VS Code, you will see that some files are auto-generated, like the Yarn RC file, and we are ready to move on. So next step is to create the workspace, and this is really easy to do with Yarn. We just run yarn init from initialize and then the W flag or the workspace flag. So now we have a workspace and we can see the structure. We have a README, a basic README, the packages that it will host our actual packages. And now let's go and create our first package, the foundation package. To do this, we will go to packages and foundation. Oops, we don't have an actual foundation folder, so let's go to packages, create the foundation folder, go to the foundation folder. So now we are in the /packages/foundation, and to create the package we just run yarn init. So we initialize the foundation package. And as we discussed, we will have React and Storybook packages. So we make the same mkd React and mkd Storybook. And we navigate to React, do exactly the same, yarn init, and go to the Storybook package. But instead of running yarn init, here we will run yarn init and then the p flag, which means that this package will be private. And this is because we will publish foundation and our design tokens. We will publish React for our component library, but we will not publish as an npm library or Storybook. So we don't need this to be public rather than private. And we can see here that we have a private flag equals true when we use the p flag. So that's perfect. And to move forward, we need to somehow make our packages dependent on each other. So we see that the React package will be depending on the foundation package, and the Storybook package will be depending on the React and foundation package. But there is something here that we need to take care of. So if we go to the Storybook package, let's say for example, and we want to add a dependency to the React package, if we just write dependency and React, how do we ensure that we mean the local React package rather than the global React package from the Facebook team? So here comes in hand the scope operator that we will use. So if we go to the React package.json, instead of having our package named React, we will use newline-ds/React. And we will do the same for our foundation file and the same for the Storybook file. So here, if we go back and we write yarn workspaces list, we can see that we have 3 packages already installed. And to add the dependency, it's extremely easy. We just run yarn and then workspace. We target the Storybook workspace here. And then we run the command add, and we add 2 dependencies, the newline ds React and the newline foundation. So if we click run, everything is completed. And you will see here that we don't target any specific version rather than the workspace version. And this basically means that this is a local dependency. And we will do the same for our React package. We just added the foundation as a dependency, and we can validate this here, that we have the foundation as a local dependency. And basically this is it. So just to recap, we started our project with yarn and set the version to yarnberry 3, and then we created all the packages and added the dependencies in the package.json. And now let's move forward and add some TypeScript and ESLint configurations. Now let's continue with our TypeScript configuration and jump back to our terminal. Now to add TypeScript to the whole project, we can run yarn add the development flag, because we will only use TypeScript in the development environment. Then TypeScript, and we can also specify the version we want to install, in our case 4.7.2. And this is done. And we can continue adding TypeScript to each package, because right now we can see we have TypeScript installed as a dev dependency to the root of our repository, but we don't have TypeScript in our React package, for example. To do this is really easy. we add TypeScript to the React package, and we are doing the same for our foundation and Storybook package. This step could be done easier with a command and a plugin for workspaces, which is called for each, and then we would execute yarn workspaces for each and the command name, in our case install the package, the TypeScript package. So we have TypeScript installed in every single package as a dev dependency, and the next step is to add a TypeScript configuration. And to do this, we can create a new file and call it TypeScript config.json. And in this configuration, you can copy and paste the configuration options you will find in the text version of this lesson. And here you don't know to need every single setting. You can search in the TypeScript website for yourself, but some important settings is the paths that you basically link everything that is hosted under the packages, the wildcard, and the folder lib. So everything that will be hosted in the compiled version of our React and Foundation package to the newline ds / and the package name. So this is basically to help our TypeScript compiler find all the local packages that we link through the yarn workspaces. And then we exclude the node modules and all the test files. So now that we have the TypeScript configuration in the root of our repository, we can extend this inside our React package. So we can click and add a new file called TypeScript config.json. And here we will paste a more minimal configuration, which is basically saying that we extend our root TypeScript configuration. Then as a base URL, we will look on a source folder. We will compile everything to the library folder. And those are React specific settings. And then also our target will be ESNext. And if we have to target low entry JavaScript engines, we can make this ES3, for example. But let's keep it to ESNext. So to see if this works, we can create a source folder and then an index.ts file and paste the following code inside, which is a really simple function called hello, takes a name, an optional parameter called name, which is a string, and it returns either the name or the word as a string. And how we can compile, so we have our source folder and we want to compile everything. To do this, we will create a script here called build, and it will use the TypeScript compiler. And to do this, we can run here yarn workspace newline react and build. And now we can see we have a new file, a new folder called lib with everything inside. So we have the index.js, our source map, and then the TypeScript definitions. And one thing to note here is that this is an ESM module. And if you're targeting libraries in your company that are more on the legacy part of things and they use CommonJS, there is a section in the text version of this course to help you find out how you can target CommonJS versus ESM consumers for your own company. And that was a wrap. And later on, we will create our own ESLint and preter configs.
Thanks for watching this Newline tutorial. If you haven't already, please like this video and subscribe to our channel. It helps other students find our content.